Write the electron configuration for each of these atoms. How many unpaired electrons does each atom have? Boron, number 5, right over there in that spot. Electron configuration, so it's going to go 1s2, 2s2, and then 2p1. This is your p block, and boron is in the second energy level, so that's the 2p row, this thing right here. And because it's the first electron in that block, you know it's going to end with 2p1. Let's draw the energy diagram, or just the sublevel for the 2p orbitals. So 2p orbitals, there's 3 of them, and boron only has 1 electron in that sublevel. So all the other ones are going to be paired. There's a pair there, there's a pair there. It's going to have 1 unpaired electron. 1 unpaired. Alright, silicon is number 14. It's right around there. What am I saying? It is there. So this is your 3p block. Alright, we know it's our third 3p because that's our first set of p's, and that is only available in the second energy level. So so this is 3p1. Silicon is in 3p2, so we know it's going to end at 3p2, the electron configuration. All right, that would be 3p3, 3p4, 3p5, 3p6. All right, so let's start from 1s can hold 2 electrons, 2s can hold 2 electrons, 2p, that's all of this stuff here, can hold 6. Right, and we just follow the periodic table. That's what alphabet says. Right, that's our 3s. Right, and then 1, 2 to get to silicon. So that's 3p2. Now there are no. Almost spoke too soon. Now, if you're just counting here, that's a pair. That's a pair. These are all paired, right? Because every orbital before the last one is going to be full in this case. Not always going to be like that. That's paired. Now you might be quick to say, well, that's paired too, because 2 is a pair. Let's take a closer look. So here's a 3p sublevel. Now, that would be paired, but that would be breaking Hund's rule. So if you follow Hund's rule, there are 2 unpaired electrons. These are not paired. All right, that's in its own orbital. That's in its own orbital. So for silicon, 2 unpaired electrons. Okay, sulfur. 2 more down is sulfur. So this is going to be 1, 2, 3, 4. It's going to end. Sulfur's right over here. So that electron configuration is going to end at 3p4. All right, so all of this is going to be the same. One s is full with 2 electrons. 2s2. Let me draw a little neater. 2p6, 3s2. 3p does not get filled up. That would mean it's over there. It's 4. It's the 4th element in that block. So 3p4. All right, let's draw the sublevel. The 3p sublevel is going to have 3 of the p orbitals, and we're going to fill in 4 of them. 1, 2, 3, and then we're going to have to pair one of them up. So we have 2 unpaired electrons. If you don't see that, you might be quick to say there are no paired electrons, or no unpaired electrons, I'm sorry. All right, but there are 2 unpaired. So sulfur has 2 unpaired electrons.